I mean, that's fair. It is Friday though, right? So there's that. All right. So my friends, let's get started and have some conversation about physics. Kind of being aware of where we're at, that, we have a test on Monday. So my plan for the day, for the next 34 minutes or however long we still have left, is I wanted to talk about the speed of sound and resonance lab with you just very briefly. I had a few lovely, some of your colleagues take some extra data for you. So if you did not get enough data on the last time I saw you Wednesday, is that right? We've got some data for you, and I also put it up on Canvas, so you've got it there as well. My plan is to just make this a review day for the most part. And that's open for whatever that looks like for you. I was going to tell you a little bit about what I looked at when I saw the former test that I have that I'm kind of working from. And then hopefully you got my email yesterday morning. Hopefully you spent a little time watching me interact with my former students, which was kind of funny, but hopefully was okay. And if you didn't, I would strongly encourage you to do that before we start class on Tuesday, because otherwise what we do on Tuesday is not going to make a lot of sense to you. So quickly on the speed of sound lab and the resonance stuff. So I have this, oops, it's frozen, so you can't see it. I have this data. So this was data that, who did this? It was Courtney and Nick, and I think Ben helped us too, or somebody else helped. Anyway, so frequency, and then they got two different ones, two different harmonics for two of them and three for a few. So all of this, and then the lengths are up there. I put them up on Canvas, so you don't have to like copy it down right now or take a picture of it. Like if you really want to, by all means. But literally, I just copied and pasted this from there as well. So that is all there. And Kian, remind me at the end of the class, and we'll talk so I can like explain to you what this means too. So this is the data that you have. You can use as much or as little of this as you feel is appropriate. Okay, because that's kind of a lot of data. But as you know, the more data you have, the better information you have. So the game is, the task at hand is to graph this information to get a straight line. And for that straight line to have a slope that is the speed of sound. Okay? So I'm going to leave that right there. I'm going to encourage you to think about it. Please talk to each other. This is not a test. So if you want to collaborate and converse about how you might do this, I would strongly encourage you to do that. But I'm just going to leave this here unless there are other detailed questions that you have for me right now. Besides, how do you do it? Because that's not the one I'm going to answer.
Is it still going to be due?
I mean, eventually, yeah. I'm going to say, let's say on Tuesday, because I don't want you to be stressed about this and the test on the same day. I don't feel like that's fair. So
yeah, and if weather's bad, it's on the first day we have school.
So, yeah, so we'll say the first.
Test on Wednesday.
We'll say.
Just ask Henry. Henry knows every day we are.
Do.
Henry's going to call us. Henry's a problem.
Not the next. Shh. Friends, the time is ticking away now, my friends, so I just want to make this clear. So, not the next time we have class, but the time after that.
I love due dates now. Every teacher's going like the time.
Right. So, not, guys, just to be really clear. So the next time we have class, which will be on Monday, we will have the test, and then this lab will be due. That means the graph and all of the associated analysis with it needs to be turned in the next time we have class, which should be on Tuesday. Okay? But I just want to make that clear that that's what's going on. Questions about that now? Is that good? Okay. So Unit 6, I was looking at the test. I was looking at kind of the things that we went over in big air quotes, right? Or that you were supposed to have read about and learned about and taken notes over and da-da-da. These are the things that I would encourage you to look at, right? The basic definitions of waves. Knowing how a wave moves on a string, how a wave moves in air, right? The differences between those things. There's a question that is a potential question on the test that's about a speaker and how a speaker works. And I know that that was something that was in some of that stuff. So we can talk about that more if you want to talk about it. Standing waves, this is the information that we had from, I don't know, one other time ago. That was the the long lecture that I did by myself, so that was kind of a slow moving one. I apologize for that. Superposition we talked about a little bit. That's when two waves interact with each other and how they add and subtract. Okay, we talked about beats, and that'll be on there, and Doppler effect. Okay, so that's the list of things that when I went through the test that I have already written, but I'm going to recraft and figure out exactly how long it'll be. That's the list of things that could potentially be on there. Does that make sense? Okay, let me say one more thing and then I'll totally answer your questions. This is what I'm expecting. So I will tell you that most of the questions that are, and by my old test, remember my old school, we were on blocks. So we had an 85-minute class. So that's why I've got kind of stuff to work with. So I'm not telling you, like, I don't know exactly how many questions will be on it because I need to think about that a little bit. But there are definitely multiple choice questions that you'll see, probably at least one or two short answer. There's also a lab-based question that's on there that I want you to see at some point. So it might look like some in class and then some take home again, okay? Just because I really want you to see that because I want you to know how to approach those. And I know that at least 50% of this is AP like material, if that makes sense, okay? As opposed to, just like random stuff that Carveling finds, which could be better or worse. I don't know. It just kind of depends. But anyway, this is vetted. So that's what I have to tell you. I saw some hands. Question?
Can you give an example of a longitudinal wave besides sound?
Yes, I can. So longitudinal waves are any wave. It's not that. It's this one. Yeah, right? Yeah, so it's any wave where the medium travels parallel to the wave motion. So the easiest one, and I can go get a slinky if you want, you can just pull a slinky out, and then if you just pull it back and then just let that wave go like this, right, then that is a longitudinal wave. In real life, like how many of us just carry around slinkies and make waves with that? Like that's kind of silly. So sound waves are like the best example. If you have studied any earth science in your experience and talked about earthquakes, they talk about P waves and S waves. I don't know if that sounds familiar to you at all, but if I'm going to say that, I think one of them is a surface wave. I'm guessing maybe that's S. I can never remember. And then the other ones go underneath. The surface waves are transverse waves, but the waves that are deep underground are longitudinal waves. So the energy from that earthquake actually travels in a longitudinal manner deep underground. So that's another really good example. So deep water waves, same thing.
Like a pendulum, that's what I said, right?
So a pendulum isn't really a wave.
Ooh.
That was not necessary. No, thank you. A pendulum, so we have to be careful here because a pendulum exhibits simple harmonic motion, right? And if you look at like a pendulum's motion over time, then it does this too, right? But a pendulum in and of itself, I would not say that that's a wave. Does that make sense?
Yeah. Well, maybe.
So the oscillation is the same.
Yeah.
But in terms of like the definition of a wave being transmitting energy without transmitting matter.
So like the motion is the same, but it's not a wave itself.
Correct. Yes.
Okay.
Yes. They can both be characterized by that sine curve, which is why we do them back to back because it's all the same. Like the math is the same, but the physical description is a little different. Does that make sense? Yeah. Isaac, did I see your hand up with a question?
No.
Okay. Or if I did, you figured it out? Okay. I was going to say, I thought I did. Yeah, go.
Could you give us an example problem over beats? Because we didn't really have anything like that.
For sure. Yes. Example problem over beats. I will tell you, and I mean this in the nicest possible way, beats problems are pretty easy. Okay, so hold on, can I?
It's like you hear this many beats.
Yeah, so like one example would be we have a frequency of 256 and we have a frequency of 258. What's the beat? It's 1 minus 2, right? Yeah. And it's always, so the beat frequency, friends, I know that there's a like, whatever. Please be quiet. Please. It's just easier. So the beat frequency is always the absolute value. So it's always going to be a positive number because you can't have a negative frequency.
So you can do 2 minus 1 then.
Yeah. 2 minus 1, 1 minus, like,
Yeah.
I'm sure in your book it says it one way or the other, but I don't know
But it
which way.
doesn't matter.
Because it's absolute value. Yep, exactly.
Yeah.
Yep. So then there might be another question.